Okay, so in this problem, we have a classical application of the Bayes theorem. So we have three events. Let's call them having H1N1, having the seasonal flu, and having neither. These three events partition our sample space perfectly. So each point in the sample space lies in exactly one of them. There is no person that has both H1N1 and flu, and there is no person that obviously has H1N1 and has neither. That's just illogical. So they perfectly partition the sample space. And so in cases where you have a complete partitioning of the sample space, you can simply apply Bayes' theorem. And then there is an event in here called having a high fever. Let's call this event, well, let's just call it high fever. And so we want to know, once we restrict our sample space to the points inside this event, what are the relative probabilities of H1N1 flu and having neither. So the classical Bayes theorem says that the probability of having H1N1, given that you have a high fever, this is just the probability of having a high fever given that you have H1N1 times the probability of having H1N1 divided by the probability of having a high fever. Okay, so if you write similar formulas for the other ones, the probability of having the flu, given that you have a high fever, is the probability of having a high fever given that you have a flu times the probability of having the flu divided by the probability of having the high fever. And then the probability of having neither, given that you have the high fever, is just the probability of having the high fever given that you have neither times the probability of having neither divided by the probability of having a high fever. As you can see, in these three quotients, the denominator is always the same thing. So if the only thing that we're interested in is comparing these probabilities, as it is in this case, it's just asking which event is more likely. So we want to just compare them together. So we can just forget about the denominator. So that simplifies things a lot, okay? But computing the denominator is not a problem. You can always compute the denominator by simply decomposing it. So the probability of having a high fever can be simply decomposed into the sum of probability of having a high fever given that you have H1N1 times the probability of having the H1N1 plus the other two similar terms. As you can see, the denominator is just the sum of the numerators in all these three quotients. Another way of saying that is that the role of the denominator here is so that the sum of these three quantities is just 1. So you can just compute the numerators and then divide them by their sum in order to normalize them to get probabilities which add up to 1. which is all Bayes is saying. Okay, so for now, let's forget about the denominators and compute the numerators. So what is the numerator here? What percent of the population has H1N1? Well, it does say that 1% of the population has H1N1, and then if you have H1N1, then there is probability 1 of having a high fever. So the numerator here is just 0.01 times 1, which is just 0.01. The numerator here is what percent of the population has flu? Well, it says that 10% of the population has the flu. So 0.1 times, once you have the flu, what is the probability of having a high fever? Well, it's just 30% chance. So you have to multiply this by 0.3, which gives you 0.03. Okay. So now for the final thing, what percent of the population has neither? Well, 89%. So you have 0.89 here, and then given that you have neither disease, 2% of the people have a high fever. So you have to multiply this by 0.02, and then once you do that, you get let me think about it. You get 1.8. 0.0 178. Okay, so the three quantities that we have are 0.03, 0.0178, and then this one is just 0.01. As you can see, this is the most likely event, then this is the most likely event, and then finally this is the least likely event. So if you want to order the events by their probability, it's highly likely that you have the flu. The second most likely event is that you have neither disease, and the least likely event is that you have the H1N1. If you want to calculate the actual probabilities, you have to divide these numbers by the sum of the three numbers, but I'm not going to do that because that just complicates stuff.